Welcome to our deep dive on creating long-form, faceless YouTube videos on complete autopilot. We handle the rendering and merging in-house, so you won't pay for external services like Creatomate. In this video, you'll watch an n8n workflow scheduled to run automatically, hourly, daily, or at your own pace. Generate a horror script, produce realistic AI voiceover, conjure chilling imagery and background music, stitch everything into a polished video, and upload it to YouTube with AI-crafted metadata, thumbnail, and tags. By the end of this tutorial, you'll be equipped to build, schedule, and maintain this fully automated pipeline yourself, your channel on true autopilot. And one of the best parts is our AI-generated metadata scores exceptionally high on tools like vidIQ, delivering top-notch titles and descriptions. Buckle up, it's going to be a thrilling ride.
The old oak tree stood at the edge of the foggy meadow, its gnarled branches stretching like clawed fingers.
All right, let's dive in. Open a fresh workflow in n8n and start building our autopilot pipeline step by step. We'll kick things off by adding a trigger node to tell the system when to run this automation. Next, insert an AI agent node. This little powerhouse will generate your horror script automatically. Give it a clear name like transcript generator so you always know what it's doing. And because we're not doing any chat-based interactions here, feel free to remove the default chat trigger node if it shows up. To generate high-quality captions, we'll use a large language model. While you can use free models like Llama locally, here we're going with OpenAI. Specifically the cost-effective and powerful GPT-4o Mini. Before moving on, make sure to enter your OpenAI API credentials. If you don't have a key, just visit the OpenAI platform to create an account and grab one. Inside the AI agent node, we'll define two prompts. The user prompt, which requests a horror story with a duration of around 2 minutes. The system prompt, which guides the AI to act like a professional horror storyteller and follow our structure. Perfect for YouTube content. Paste those prompt templates from the long-form autopilot community lesson into the respective fields. Now hit test step, and you should see your first AI-generated horror story. Now that we have the script, it's time to create the voiceover. You can use services like 11 Labs or stick with OpenAI's native text-to-speech. For simplicity and consistency, we'll use OpenAI Voice here. In a new OpenAI node, drag in the output from our AI agent, the horror script. Choose your voice. For now, we'll stick with the default Alloy voice. Don't forget to select your API credentials. Test the step, and voila. You now have an MP3 voiceover file named Data. Download the MP3 file to your computer. Let's listen to the generated voice to make sure it sounds just right.
The fog rolled in thick as a woolen blanket, muffling the sounds of the world outside. Sarah shivered, not from the chill, but from the sense that she was being watched. She had come to the old cabin, nestled deep within the...
While OpenAI voices sound decent, they lack that creepy atmospheric vibe that truly pulls viewers into a horror story. So instead, let's use the 02 Launch Text-to-Speech API, available exclusively for our premium members. It's still powered by OpenAI under the hood, but we've customized each voice with unique vibes tailored to different genres, including horror. In n8n, drag in an HTTP request node to replace the OpenAI voice node, open our docs, and grab the curl request for our TTS API. Paste it into the Import curl section of the HTTP node, and it will autofill the setup for you. Next, paste your XAPI key. You'll get this as soon as you join our premium community, directly into the request header. Then drag the AI-generated caption from the previous node into the text field of the JSON body. Since our caption may contain characters that break JSON parsing, we'll wrap it in a simple replace method to sanitize any invalid symbols. Just copy the ready-to-use snippet from our community lesson, and you're all set. Before moving on, switch over to the Settings tab of your HTTP request node and turn on retry on fail. Set it to retry 3 times, waiting 3 seconds between each attempt. That way, if your internet hiccups or the server is momentarily unreachable, n8n will automatically try again. No need for bulky loop nodes that can bog down complex workflows. Remember, loops are great when you have a batch of tasks to repeat. But for simple single API calls like polling an endpoint or rechecking your request status, you'll want to skip the loop node altogether. Instead, use this retry approach. It's faster, cleaner, and you can even apply it to check video generation status steps, avoiding the bulky loops you see in other tutorials. Now it's time to give our narration that unmistakable horror movie edge. Head over to our GitHub repository, where you'll find every available voice and vibe, along with genre-specific recommendations from the community. For our spooky demo, we'll choose the Ash voice paired with the Noir Detective vibe. Simply update those settings in your HTTP request body, then hit test step one more time and play back the result. Listen closely. See if it sends a chill down your spine.
The fog rolled in thick as a woolen blanket, muffling the sounds of the world outside. Sarah shivered, not from the chill, but from the sense that she was being watched. She had come to the old cabin, nestled deep within the woods.
It's warm, immersive, and perfectly evokes the kind of campfire ghost story feeling we're after. Now that you've got your audio in the data file, it's time to turn it into a URL we can feed into our video rendering API. We need a publicly accessible endpoint, in other words, an audio URL. To do this, we'll add a node that transforms the data file into a base64 string. Alright, next we'll drag in a new HTTP request node to upload the base64 string to cloud storage. We'll use Cloudinary, which offers 25 GB of free storage per account. So if you don't already have one, go sign up and grab your cloud name from the dashboard. In the node's URL field, paste your Cloudinary endpoint, replacing the placeholder with your own cloud name. Then head to your Cloudinary account settings and create an unsigned upload preset. Think of it as a configuration profile for your uploads. Name it something meaningful, set it to unsigned so you don't need API keys for every request, and choose a folder, for example, longform_n8n, where your audio files will live. Hit save. Back in workflow, first head over to the header section and set accept to application JSON. Then move to form data and add 3 key fields. The first is public_ID, which defines the file name for your upload. To generate a unique name for each audio file, let's add a function node before the HTTP request. Copy the random string generator snippet from our community lesson. Paste the random string generator code here. This will create a new unique string for each base64 payload. Hit test step. Because the base64 encoded audio payload is so large, let's rerun the workflow now. You should now see a freshly generated public_ID value in the output. Now that our function node has generated a unique public_ID for the base64 audio payload, let's wire that into our HTTP request. In the form data section, select the public_ID field and map the output from the function node. This ensures each upload uses its own random file name, keeping our Cloudinary folder organized and collision-free. Next, add upload_preset, matching the name of the unsigned preset you created. Finally, include a file field and drag in the base64 string of your audio from the previous node. Hit test step again to see the results. Because our base64 payload is so hefty, you'll need to rerun the entire workflow. And voila, you should now see a secure_URL returned by Cloudinary. This audio file lives in the folder you specified under your long-form n8n preset. And the file name matches the public underscore ID we generated earlier. Let's click the URL to confirm it plays back the exact audio we created.
The mist rolled thickly through the woods, wrapping the tall trees in a ghostly embrace. Each breath Henry took.
Next, we'll clean up that response, add an edit field node to pull out just the secure underscore URL, and rename its output to something meaningful like audio URL. Drag the secure underscore URL into the value field. Rerun the workflow one last time, and you'll have a neat audio URL ready to pass to your video rendering backend. Now, because encoding long audio into base64 each time can slow down testing, even for single node changes, we'll streamline this step by swapping in our 02 launch TTS API. First, disconnect the HTTP request node that was handling the base64 conversion. Then open the 02 launch API documentation and locate the text-to-speech endpoint that returns a ready-to-use audio URL. All you need to do is replace the URL in your HTTP request node with the new API endpoint. Hit test workflow, and you'll instantly receive an audio URL without the heavy base64 conversion. This link stays active on our server for 30 minutes, so feel free to open it and verify your horror narration is spot on.
In the depths of the fog-laden woods, an unsettled...
Next, we'll use an edit field node again to pull out just the audio URL from the 02 launch response. This is the link we'll send to the video generation backend. Simply map the audio URL field into a new key, also called audio URL, test the node, and you'll have a clean URL ready to feed into your rendering pipeline. Now that we've streamlined our audio step, you can test that node in isolation. No need to rerun the entire workflow every time. Go ahead and delete any old unused nodes to keep your canvas clean. Next, we want our workflow to automatically continue by generating images and background music before finally rendering the video. To orchestrate that, let's add a merge node in combine mode. We combine items based on their order and set it to expect 3 inputs, one for audio, one for still images, and one for music. Since we already have our audio URL, connect that output into input 1 of the merge node. For input 2, we'll kick off our image generation process. Add an AI agent node, just like we did for the voiceover, and supply it with your system and user prompts to produce the perfect still image that matches your horror theme. Just grab the system prompt we've shared in the community lesson and paste it into the AI agent's system prompt field. Then, drag the transcript generator's output into the user prompt slot. This way, the LLM sees the exact story context and can conjure up a still image that perfectly matches your horror theme. Be sure to select a chat model for this AI agent node. Just like before, choose the OpenAI chat model. Now hit test, and you'll see a well-crafted prompt ready to feed into your image generation service to produce that perfect horror visual. Next up is image creation. You can plug into any image generation API. OpenAI's DALL-E, FAL.ai, or Leonardo.ai, whatever you prefer, but let's start with OpenAI's DALL-E. Drag in a new OpenAI node right after your AI agent. Set the action to generate image and pick the DALL-E 2 model. Then, drag the text output from your AI agent into the prompt field. Don't forget to flip on respond with URL so you get back a link instead of raw image data. Connect your OpenAI credentials, hit test step, and within seconds, you'll see a URL pop up. Open it to preview your horror theme still. Once you've confirmed the image looks right, add an edit field node to rename that URL to something clear like image URL. and map the return link into it. Now you have a neat image URL. You can pass downstream. But to keep your costs down as you scale up, we'll swap out the OpenAI image node for our 0.2 launch image generation API, unlimited images for premium members, link in the description. Replace your OpenAI node with an HTTP request node, then hit import Coral and paste in the 0.2 launch example from our docs. Fill in your XAPI key header, map the AI agent's text into the prompt field, and set your desired width and height. To ensure fresh variations each run, remove the seed parameter so the API will automatically randomize it behind the scenes. Choose the flux model. Also, toggle retry on fail. Set wait between tries to 3 seconds and hit test step. In no time, you'll get back your new image URL. Give it a click to verify. All right, we've got our horror image. Now let's use an edit field node to pull out and rename that URL. Now just drag the image URL from the HTTP request node's output into the value field. All right, now that we have our image URL ready, let's connect that edit field node to input 2. Remember, we want images to come in right after the audio stream. To keep everything organized, take a moment to rename your nodes with clear descriptive titles so your workflow stays easy to follow. Next up is background music. Drag in a Google Drive node and choose the Search Files and Folders action. If you haven't already, create a Google credential. Just paste in your client ID and client secret. We've got a tutorial on that in the description. And don't forget to enable the Drive API in your Google Cloud Console. We've also shared a Drive folder full of free horror tracks. You can download link in the description, then let's upload them to your own account first. Then configure the node to filter for all MP3 files. Hit test step, and you'll see each audio file's name and ID come back. To match each file with its license info, we've prepared a Google Sheet, where each row lists the file name without the MP3 extension, a direct download link, and the required attribution text. All of our background tracks come from the Bensound Sound website, which offers a selection of free audio files. Just search for the horror category. Download the ones you like, and to stay copyright safe, include the required attribution text and free license notice in your video description. We've already downloaded these files and added their attribution text in the sheet so you can use them immediately. When you pull the file IDs from the Google Drive response, you'll construct each download link using the same URL pattern. You'll notice only the ID value changes. If you paste one of those URLs into your browser, the MP3 will start downloading automatically. Alright, back in n8n, connect your transcript generator output to the Google Drive node. So this search only runs once your image is ready. Then wire that node into input number 3. Now, to pick a random track each time, drop in a function node that pulls one object at random from the Drive response, grab the snippet from our community lesson, and paste it here. This gives you a clean file name to look up in your Google Sheet. Each time this function node runs, it picks a random file object, complete with its file name and ID from our Drive response. But in our Google Sheet, the title column only holds the file name without the MP3 extension. To match them up, we'll tweak our function code to strip off that extension. Copy and paste the updated snippet, hit test step, and you'll see a clean file name ready to map against your sheet. Next, add a Google Sheets node configured to get rows. Make sure your credentials are correct. Then select the sheet containing your background music data. Under Filters, set it to look for the title column. Drag in your function node's clean file name as the filter value. Run the test step on this node, and you'll receive the entire row that matches the file name from the function node, complete with its download link and attribution text. Actually, you can skip the Google Drive lookup altogether and pull all your audio data straight from the Google Sheets node, but we're demonstrating this step so you see exactly how Drive file IDs become downloadable URLs. Now wire your Sheets node into input number 3. Let's run the test workflow. You'll notice the audio flow runs first, which is input number 1, then it runs the image flow, which is input number 2, and finally, the background music flow. Once all 3 complete, the merge node outputs exactly the URLs and metadata you need. Before we hand these off to the video render, let's clean up that JSON by adding an edit field node after the Sheets node to remove everything except the background music URL and attribution text. So in this edit field node, let's pull out only the background audio URL and the attribution text from the Google Sheets response. All right, run the merge test again, and now you'll see just the 4 key values: audio URL, image URL, background audio URL, and attribution text, all set for your final video generation. Awesome. Next, before we fire off our backend to render the final video, let's automate your YouTube metadata title, description, and hashtags using an LLM. That way, you won't lift a finger. Start by adding an AI agent node. Before you dive in, make sure to fill out both the system prompt and the user prompt and toggle on the require specific output format. We'll use that setting to parse the AI's response cleanly later. For the system prompt, paste in the copywriting instructions from our community lesson. This prompt asks the model to act as a professional copywriter and generate YouTube metadata in a specific JSON format based on the user prompt. The format will clearly include 3 fields: title, description, and tags. For the user prompt, drag in your transcript text. This gives the AI the context it needs. As usual, our AI agent needs a powerful LLM to generate content. So for this node, select the OpenAI chat model, then hit test, and you'll get a raw JSON response where each field is separated by /n, the line break character. To make that human readable, make sure to toggle on Require Specific Output Format and choose the Structured Output Parser. Paste in an example of the exact JSON schema you want: fields for title, description, and hashtags. Now, when you test again, the AI's response will be neatly formatted into those 3 fields. Awesome. All right. Rename this node to something clear, like metadata generator, so you always know its purpose. Now that we've gathered every piece of data, your audio URL, image URL, music URL, and metadata, it's time to stitch them into a final video and push it straight to YouTube. First, we need to combine our 3 media assets. Normally, you might reach for a paid service like Creatomate, but fees can skyrocket as you scale. Instead, we'll tap into the power of FFmpeg, an open source wonder that can merge audio and images in seconds. All right, let's get started by firing up your favorite code editor, or just open a terminal window. Create a new project folder, and inside it, drop a Python file. Call it like video API background music.py. Copy in the backend code from our community lesson. This script will expose a post endpoint that takes image URL, audio URL, and background music URL as parameters. Under the hood, it downloads each file and then runs FFmpeg to combine them into a video at YouTube-friendly resolution and returns the finished file. Now let's open the terminal, navigate to the project folder, and spin up a virtual environment by running this command. Here we give the environment a name like my env, and then we activate it. Next, install the required packages. We need to install the project's dependencies before importing them in our script. Just grab the install command from our community lesson and paste it into your terminal. Notice we're installing a package called gdown, which makes downloading and handling Google Drive links seamless. So whether you pass a direct MP3 URL or a Drive file link, it just works. We'll also install Unicorn, which runs our API server and automatically reloads whenever we make code changes. So let's go ahead and run a command to install it. Once everything is installed, let's launch our server file using Python command. You'll see it up and running on localhost at port 8888. If your n8n instance is on the same machine, you can point to this endpoint directly in your HTTP request node. If you've deployed n8n on a remote server, like a VPS, you'll need a way to access to the API endpoint. The simplest solution is ngruck to expose the local host endpoint. First, sign up for a free ngruck account and install it on your Mac or Windows machine. Next, we authenticate your setup by running the ngruck auth command with the token from your dashboard. This links your machine to your ngruck account. Finally, run ngruck http 8888, since that's the port where your server is listening. This will spin up a secure HTTPS tunnel and give you a public ngruck URL that forwards to localhost on port 8888. Alright, let's copy and paste this URL into our n8n HTTP request node, and now your remote workflow can trigger your local API just as if it were hosted on the internet. Don't forget to add /generate video at the end. That's the endpoint we created for running our API. Next, toggle on the send body option and map in your three URLs, image URL, audio URL, and background music URL directly into the Generate Video API payload. These URLs come straight from the merge node's output, so just drag them into the request body parameters. So let's quickly set that up. Once everything's in place, click Test Workflow to kick things off. In your terminal, you'll see the API log the steps, downloading each URL, running the FFmpeg to stitch the audio, image, and music into a single seamless video. For a 4-minute clip, it takes about 20 seconds. When it finishes, the node returns a data file, your final MP4, about a 12 megabyte file. Click View to download and preview your horror short.
The fog lingered thickly over the abandoned town of Witheridge, its decrepit buildings looming like skeletal fingers grasping at the sky. Clara had heard the whispers. The townsfolk had vanished decades ago.
Awesome. And now the moment of truth. Let's upload the video with its metadata to YouTube. Our horror masterpiece goes live. Add a YouTube node and choose the Upload Video action. Map your generated title, description, and tags straight from the metadata generator node, and don't forget to set your region code and category. For the video file itself, point to the binary output named data from our previous HTTP request. Next, let's enable the description field in the node's options. Drag your AI-generated description and tags into the description field, then preview it to make sure everything looks flawless. It looks perfect. Excellent. Make sure to enter your Google credentials and enable the YouTube Data API in your Google Cloud API library. In the API library, just search for YouTube and enable the YouTube Data API when it appears. Once that's done, hit Test Step, and in just a few moments, you'll see an upload ID pop up. And just like that, head over to your channel and you'll see your newest horror video live, complete with an AI-generated thumbnail, a score-optimized title, and a perfectly formatted description, all set to thrill your viewers. Let's hit play to confirm everything looks and sounds just right.
The fog lingered thickly over the abandoned town of Witheridge, its decrepit buildings looming like
Very good. To make it even better, let's wire our hashtags field into the node's tags option. This cues YouTube to use our tags behind the scenes, helping the right viewers discover our horror content. Finally, let's append the attribution text to the end of our description. This way, we're fully copyright compliant and giving proper credit where it's due. Now you'll notice the description now bundles everything together: the chilling horror synopsis, our targeted hashtags, and the music credits all in one seamless block. This not only tells viewers exactly what to expect, but also keeps you fully compliant and helps YouTube's algorithm deliver your video to the right audience. Before we queue up our next horror upload, let's clean house, delete the last video that missed its music credits. Then in n8n, swap out the manual click trigger for a schedule trigger node. Choose hourly, daily, or whatever interval suits your channel's cadence, and you're all set. Now hit save, then activate the workflow so it runs in production according to your schedule. All right, let's run one more test and watch as a brand new horror video is generated and uploaded all on its own. Once everything wraps up, you'll see the YouTube upload node return an upload ID. That's our confirmation. Head over to your channel and you'll spot a brand new horror video waiting for you. Run it through a tool like VidIQ, and you'll see the title scored 92, which means it's primed for engagement.
The mist rolled in thick as Eleanor stepped into the twist.
The video is awesome. Sit back and watch your Autopilot channel come alive. No manual uploads, no missed credits, just fresh, spine-tingling content hitting your audience on schedule. And that's a wrap on our fully automated faceless horror video pipeline. From script and voiceover to imagery, music, metadata, and automatic YouTube uploads. If you found this tutorial valuable, be sure to join our 02 Launch Premium community, where you'll get unlimited access to our custom TTS and image generation APIs, exclusive prompt libraries, and member-only support. Fire up your workflow and let AI do the haunting for you. See you on the other side.